there's a polynomial, 2x cubed minus x squared minus 13x plus k, where k is a constant. And they want you to find this value of k, given that p leaves a remainder of 6 when divided by x minus 2. So this one you're supposed to use remainder theorem. So if you let px be equal to this equation here, that's what we always do for factor and remainder theorem, because it's easy to replace the value of x when you express it in this way. So it's essentially given, right, that when you do a p2, when x is equal to 2, which is from this, all right, then that will give you 2 times 2 cubed minus 2 square minus 13 times 2 plus k, and that's equal to 6, your remainder. So you just simplify your left-hand side. And it's k minus 14 equals to 6. So k is equal to 20. All right, it's a 2 marks question, so it's pretty straightforward. So come to part B. In the case where k is equal to negative 6, this quadratic expression is a factor of p. Find the value of the constant a. This is a little bit hard, but first of all, let's just establish our px. This is 2x cubed minus x squared minus 13x minus 6, because it's given that k is equal to negative 6. So the fundamental idea for this question, how you're supposed to solve it, is by using long division. And you're supposed to get all your factors lined up all together, and then you try to infer the value of this a. Okay, so to make things simple, I think you can try to use factor theorem on this first. So find a value of x that you can sub in to get the linear factor of this equation. So as I mentioned, for cubic factorization, the values of x that you should try is 1, negative 1, 2, negative 2, 3, negative 3, in this order. Okay, because it's simply easier to deal with 1 compared to 2 compared to 3. So 2 times 1 cube, use your calculator, minus 1 square minus 13 times 1 minus 6. Do you get a 0? Yes or no? So the answer is no. I got a negative 18. So if I use negative 1, I will get 4. So I move on. If I use 2, I will get negative 20. If I use negative 2, I will get 0. So actually, negative 2 is one value that we can sub in. Okay? But that is what's given earlier also. Negative 2. Yeah. So let's try 3 and negative 3 anyway. So 3 will also give me 0. Negative 3 will not give me 0. So what I found just now, 3 and negative 2 both give me 0. So p negative 2 equals 0, and p3 gives me 0 actually. All right, so actually I found 2 linear factors using this method. Usually you stop at the first one, but just so happened that we have more than one. So hence, x plus 2 is a factor of px. And this one tells you that x minus 3 is a factor of px. You can, of course, combine both of these into one single statement. All right, so you can say, hence, x plus 2 times x minus 3 is a factor of px, actually. And this is actually quadratic. All right, so we do a long division over here to figure out the last remaining one. So our px is 2x cubed minus x squared minus 13x minus 6. We divide this by the expanded product for this one. So this actually gives us like x squared minus 3 plus 2, so negative x minus 6. Okay, then let's divide. So this gives me 2x, so 2x cubed minus 2x squared minus 12x. All right, and when I deduct this off, I will have x squared positive 12 minus 13 minus x, and then minus 6. So here just plus 1 to give me x squared minus x minus 6. So when your divisor is longer, your working for long division tends to be shorter because just 1 or 2 divisions and you're done already. So with this, we've figured out the last remaining factor for your px. So hence, px is equal to x plus 2, x minus 3, which we found earlier, and 2x plus 1, the last remaining one that we found just now. Okay, so come back to the question again. It says that it's given that the quadratic expression 2x squared plus ax minus 3 is a factor of p. Then they want you to find this constant a. So when you look at this x squared term, this has a coefficient of 2. And when you look at this constant, it's a 3. So that means you're looking at 2 of your factors combined together, where one of it has a 2x inside, and the constants should multiply to give you a 3 also. Okay, so it should be very clear which one it is, because I want this 2x here. So that means I'm stuck with this 1. I have to take the whole bracket. So to get my 3 as a constant, this is the one that I go for. Okay, so hence this is equal to x plus 2. I don't touch this, and then I expand this one. So this is 2x squared minus 6x plus x, so minus 5x, and then minus 3. So when I look at this, and I compare to this expression that's given to me, 2x squared plus ax minus 3. So I actually match my 2x squared and negative 3. So next, I just simply need to infer my value of a by comparison. So hence, a is equal to negative 5. Okay, it's not a very straightforward type of question,